Assalamu alaikum and hello everyone. Today we are going to talk about state-of-the-art avionics system, safety and emergency. So as we can see here, we have table of contents. So at first we have an introduction, then history of safety and emergency avionics system, and after that we'll have methodology part, then analysis, and after that discussion, and finally conclusion. In introduction, we can have so many questions such as what does safety and emergency system mean and how is it important? Or we can ask what is avionics safety system mean and how does it work? We should know that the safety of people is the first thing we have to work on in order to make sure that all people and passengers are in safe. And because of that, now we have a lot of modern technologies to aid us in security against whatever disaster might happen. Also, we can identify avionics safety and emergency system as a software and hardware system that work with modern technologies and able to work better with more complex technologies in avionics. This system has to identify risks and problems, analyze, assessment, and manage them before any disaster happen. It's also identifying the accurate magnitude and the percentage of any disaster probability. After that, the safety system will give the most suitable solution to avert any bad consequences.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to Dr. Zairil, Dr. Amzari, and our fellow friends. My name is Noor Amirudin bin Azlan. My matrix number is 208062. I will be explaining about history of aviation safety and emergency. Okay. On the 17th of September 1908, which is 4 years after the first flight and 5 months after the first passenger were carried by an airplane, Olby Wright crashed during a flight demonstration, and at the moment, there was a passenger who on board was who is Thomas Selfridge. Okay, due to this crash, a history of first aviation fatality has been recorded. Thomas Selfridge, who was the passenger, was killed, and the pilot, Olby Wright, suffered a serious injuries. However, this accident did not stop the aviation from developing and resulting to more planes and flight being conducted. The development of aviation to really achieve its full potential as a mainstream form of travel is an ultimate goal of the technology industry, as it will help a lot in traveling process. But due to the crash cases that increasing daily, the leader decided to put some rules and regulation on the aviation to help reduce the case of crash. This result to the establishment of the Bureau of Air Commons in 1926, along with the Air Commons Act, as a way to oversee regulation and promotion of the air transport. In 1938, Civil Aeronautic Agency has been created due to the aviation crash of Senator Bronson M. Cutting, who is the Senator of United States in 1935. The agency originated to separate into regulation of air travel from the Department of Commerce and give the ability to regulate and investigate flight safety. After that, it have been separated into two agencies, which is which are civil aeronautic agency who controls who control the oversight of national airspace system and air traffic control. Meanwhile, the second agency is civil aeronautic boards who control aviation safety regulation, oversight and economic control of airline routes. Lastly, the cockpit voice recorder and flight data recorder has been mandated in 1967. Investigator got a first-hand look at the operational parameter of an aircraft prior to the crash for the first time ever, as well as some insight into that the crew was doing, thinking, or saying during the event of accident. This revolutionized the air safety because it made it possible for the inspector or investigator to glimpse accident information that could be used to avoid potential accidents. This this cockpit voice recorder and flight data usually we known as the black box of the airplane. That's all. Thank you.
Assalamualaikum. My name is Amirun Akif bin Ahmad Jasrul, and my matrix number is 207449. And I will be presenting the methodology part. So, moving on to our points, what will be discussed in the methodology in the topic of safety system and emergency of avionics. So, there are three parts that can be divided in this methodology. The first point is system organization architecture of integrated avionics system. So in this section, both explains which is layers in integrated avionics system organization architecture and implementation architecture of integrated avionics systems, how they function and what the objective that they were introduced. They also show what they were designed for. So moving on to the next point, which is hazard control for avionics systems. Area must be defined on the basis of the system organization design of the integrated avionics system. This can be achieved by a secure evaluation process in the first place in order to guarantee the safety of integrated avionics system. So the second point of this hazard control is analyzing device safety criteria, danger modes, and hazard management process. With the help of experts like preliminary hazard list technology, preliminary system safety analysis, and the system safety analysis. The last point in this part is the design of a safest method of production and evaluation, as this help to remove the mistakes made on the aircraft itself. And lastly, engineering process-based hazard control for avionics system. In system safety analysis process, we will understand each role and the sequence in the safety analysis itself. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Iman bin Ahmad, matrix number 205901. I will be explaining analysis of safety and emergency system measure. So let's start with event classification. There are 4 different types of emergency, class 1 until class 4. So emergency class 1 is the most dangerous and life-threatening. So it will need, when the sensor pick up the emergency, it will need immediate response by the crew. So warning class 2, it also dangerous but doesn't need that immediate response by the crew. So the crew need to take action within 5 minutes. Emergency class 3, or we call it caution, is classified as those situations that need less time critical. So it doesn't need that immediate reaction by the crew. So emergency class 4, or we call it advisory, is mainly for the ground crew and it doesn't need the immediate reaction by the crew on flight. Let's go to data sensor, probability of false alarm. So every event in the flight is being monitored by a sensor. When the system pick up emergency signal, it will inform the crew to take immediate reaction. So, example, I am a passenger and I'm not that gentleman and I doesn't follow the rule. So I want to smoke in the flight. So I go to the toilet and start smoking, and the sensor will pick up the smoke detection. It will detect there's a smoke in the flight, and it know it just smoke and not fire. That it doesn't trigger the fire alarm. So the last one is failure isolation and recovery. As the name suggests, failure detection and way to recover from it. Its main purpose is to inform the crew. The easiest example is rapid changes in atmospheric pressure. So it will inform the pilot there's changes in atmospheric pressure, and with a push of the button, and the breathing equipment will pop up and help the passenger to breathe. It is one of the safety feature in a flight. So that is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhan and Faizeen bin Rozaimi Yazi. My matrix number is 206.1. So today I'll present the discussion of flight safety and emergency. First of all, I will explain the two situations that may occur during flight. The two situations is abnormal and emergency situations. Emergency situation is when the safety of the aircraft or people on board and on the ground is endangered for any reason, while abnormal situation is when it is no longer possible for the aircraft to continue the flight using normal procedure, but the safety of the aircraft, the person on board and on the ground is not in danger. For example, aircraft component failure or malfunction, aircraft damage, and worsening weather conditions. These conditions can make it impossible to continue the flight as planned to the destination and may require emergency landing. So, engineer has installed safety features within the aircraft. So, the safety features installed is the aircraft design itself and safety equipment inside the aircraft. So, the wing is designed to provide lateral controlability and to pre-stall warning at low airspeed and high angle of attack. While safety equipment inside the aircraft is, for example, smoke detectors, fire extinguisher, and oxygen supplies. These equipment are used to prevent any hazard that may arise along the journey. So this can, with the fire extinguisher, for example, we can put out the fire if there is any fire inside the aircraft. So this can guarantee the people on board safety. Last but not least, safety equipment along with the aircraft design and material itself are the crucial features that are required in order to secure a safety flight along with the passenger well-being. That's all from me. Thank you.